Welcome back to Learn to Code in Python. So this is our day 3 in our DSA learning series. So yesterday we had practiced some interesting problems using array traversal to create a Pascal's triangle, and then we were able to find out longest square streak in an array, and we were able to find out maximum subarray. These problems were interesting and mostly were using array traversal. So now today, we have three interesting problems in our agenda, and it is a fun mix of different challenging problems. So it requires a sliding window and then some strategic thinking and dynamic programming. So let's jump right in. So first problem which we are going to discuss today is determine the winner of a bowling game. So this problem is quite simple and easy. So and you are given a two array for player 1 and player 2 scores in a bowling game. So how a bowling game works is you will bowl and you will be able to hit n number of n number of pins out of 10, and what happens is if you hit all 10, so in the next round your pins, you hit 2 pins, it will be doubled and your score will be counted as 4, and it happens to next 2 rounds. So that is the logic of a bowling game. So whenever you bowl, basically if you hit a 10, then your next round score will be doubled. So that is the base logic. And if you hit less than 10, your score will just add it with that particular number of pins. So this looks simple and straightforward. And let's just see an example of how the calculation works. So if your player has a bowled 5, 10, and 3 and 2, so your total score for player 1 will be 5, then plus 10, then 2 into 3, and then 2 into 2. Overall, it's 25. Same way for player 2, if it is 6, 7, 5, 3, then it's just a standard addition of 6 plus 7, 5 plus 7 plus 3. It's 21. So right now, player 1 wins. And in our case, they are expecting us to return 1 or 2 if 1 in case of player 1 wins, and if 2 in case of player 2 wins. And if it is a draw, will return a 0. So this is how my solution looks like. Basically, we will initialize a couple of windows and we will initialize couple of variables for storing values. And whenever and we run a simple for the list of values which we have got as the scores. And this simple loop, initially what we do is we add the number of pins to the respective player total. And if the length of window is greater than 0, so then can check if something is there in the window. We are initializing a sliding window of 3 scores, maximum 3 scores, and if which will contain the current score and then previous 2 scores, and if any of it is within 10, then we are adding the score again. So instead of into 2, we are adding it again. So that's how it works. So just to show a good visualization of how this works, so I've created this visualization where I'm putting all the values and I'm going to click on a start game. So what happens now is your current window of player 1 is 5, current window of player 2 is 6. So your total score of current scores is 5. And on the next round, your window increases 5 and 10. Both of them is part of the window, and current player score is player 1 score is 15, and then player 2 score is 11. So in the next round, we will be going and checking 3 and 7. Now, since the window in the window there's already a 10, so this 3 will be doubled. So we'll add 6 to the player 1's total, and in this case the 7 will be as is. So total is going to 21 and 18. So bonus 3 is applied. So the next round we are actually adding 2 because the player has bowled a 3 2 turns back. So right now overall score of player 1 is 25 and player 2 is 21 and player 1 wins. So this is how this particular problem was solved by me, and I have submitted the solution and it looks very well. let's move on to the next problem. This is also quite interesting, and again, today we are picking winners. So this is an interesting game where we'll be predicting the winner. So the problem is you have an array. You have an array of numbers, and maximum numbers you will be getting is 20 numbers in that array, and your number value can be equal to anything from 0 to 10 to the power of 7. So in this game, player 1 and player 2 takes turns and pick one number from either end of the array. So if your array is 1, 5, 2, 2, 3, 3, and 7, your player 1 can pick, whenever player 1 starts, he can pick a number 1. So the player 2 can choose either 5 or 7. So overall, your number, the next number will be picked up by player 1, so he can pick the 200. So we will add the numbers which each player picks on each and every turn, and we need to determine whether player 1 will win or player 2 will. So that is the simple logic of this game, and for this what we are doing is we are creating a array. I mean, we are creating a multi-dimensional array and setting it with 0, and we are going to calculate the differences. We are going to calculate the differences, and based on that we will be figuring out which which player will have difference, positive difference. Based on that we'll figure out whether it is player 1 or player 2 as 1. So that's how this logic is going to look like. So for this I've created a visualization. Let me go to the visualization. Okay. So right now, when the array, the array which we had saw, the array with 1, 5, 2, 3, 3, and 7. So on the initial loop, we will the difference will be 7, and the choices will be to pick either left or pick either right. If you pick left, then the total of this one will be 233. And if you pick right, it will be 226. And same way, next step, again, your choices will be either to pick left or pick right. So if you pick left, then your total will be 228. And if you pick right, this difference will be 228. Positive difference will be 228. Negative difference will be 220. Same way, you can either pick left or right. Based on that, your difference will be 229 or 222. So in this logic, basically the player 1 wins. So we are figuring out using this recursion technique to find the difference of the numbers. So that's how we are figuring out the winner in this case. So let's move on to the another interesting problem. The next interesting problem is a sliding puzzle. So, and again, it's one more game which we are having today. So this sliding puzzle is quite simple and straightforward. We have a 2 cross 3 board, and there are 5 tiles labeled from 1 to 5 and an empty square. So most of you would have played this game. You'll move a square to that empty square, and you have to rearrange it to a specific order. So for example, your board is carrying 1, 2, 3, 4, 5, 0. Then you need to set it to 1, 2, 3, 4, 5, and then 0 at the end. That is the state which you want to be on the end. So to get to this state, how many iterations or how many steps or swaps you need to do. So that is the thing which we need to figure out this particular problem. So to understand, to solve this particular problem, we'll be using BFS, breadth first search, and we'll be using the queues as well. So how this solution works is we will save the two-dimensional array into a string, just for figuring out the So our target state is always going to be 1, 2, 3, 4, 5, 0. So we are going to put this two-dimensional array into a single string and the directions. So if 0 is there in the first position, then it can move to the index of 1 or index of 3. Meaning the index of 1 is, our string index starts from 0. So if your 0 is empty space is in the first position, it can move to index 1 or index 3. That is the two positions it can move. Same way, if it is in first position, it can move uh, 2 or 4 and so on. So at any given point in time, at any given position where you have an empty space, you can move in two in any of this. I mean, you can use any one of this solution. You can either move it to point 1 or you can either move it to point 3. So you can move the blank any one of this position based on this directions. So now what we are going to do is we are trying to figure out, like, given an position like this 4 5 and then 1 2 3, what will we do? Basically we will move. So I have created a good visualization for this as well. So when your position is like this, what will you do? You will move the 5 first. So, and then you will move the 4 next, and then you will move 1 next here, and then we'll move 2 next here, and then we'll move 3 to the next. So overall, this is the optimal solution. We'll take 5 steps for this to achieve. But when we think of scenarios, so this is a overall solution tree for us. But when we think of scenarios, you can move either 5 or 3 or 1. So you have 3 different options in. So this is what is breadth first search means. Basically, we will create a set of, we will move through the all possible iterations, and this is first iteration. So the first step, and now here also it will try to do all of the possible scenarios as well. Okay. So here, when it is moved like this, so all of the possible scenarios at each layer, we will save all of these possible scenarios till we reach the target state of 1, 2, 3, 4, 5, and then 0. So here, the possible scenario is you will move this 4 to below, or you will move this 5, this one, but it will be returning to the original position. So we have discarded. So now again you have two options only. You can either move 1 here or you can either move 4 here, but 4 will be giving you the same position, so we are discarding it. So at the end here you can do same way. You can do 3 options, but again one of the option will be an redundant one, so we are not doing it. So when your blank space is in either of this location, you will get maximum of 3 options. One of it will be the previous option, so we'll skip it, but remaining 2 options are valid. So again, once this so in these two solutions, again we will try and expand this one. So this is the actual solution which will give us target. So to attain this stage, how long we have to travel? 1, 2, 3, 4, 5. So we took 5 steps. So this is the result we are expecting. And overall, if you try and see this 5 stages, we will expand for everything. So until we get the proper result. And again, if we are not able to get it, if you are not able to get that result on that 6 iterations, then after all of this iteration, then we will mark it as -1. So that's how this particular solution is gonna look like. So this visualization will give you a better understanding on how we are arriving with the solution. So now let's go back to the code. So in this code, what we are doing is we are initializing a queue with the start position and the start index of 0, start index, to figure out where the 0 is. So that is what is going to be the index which is going to be passed. And we are going to set this moves as 0. So every time when you get a list of every time when you uh, get, I mean, if you want to figure out if this position is already visited or not, so that is where we are using the set to remove any visited, I mean any already visited options. So in this loop what we are doing is we are trying for all the possible swaps of 0, and if it is not there in the visited, then we'll add it into the visited and we'll append it into the queues with moves plus 1. So, and after this entire loop, after this entire loop, if at all if we don't get the result, we are returning the minus 1. So that is how I was able to solve this problem. So with this we have covered the three problems which we wanted to solve today. We have had an interesting problems, and we have tried different solutions. We have used techniques like sliding window, dynamic programming for breadth first search, everything in today's window. I mean today's video. So if you want to know further about this problems or how to solve this, please do give a shout. I can create some more videos giving a detailed explanation on how it works. So that's it for today. We'll see you tomorrow. If you have found that a video helpful, please do like, share, and subscribe. That will be a booster.